All right, scalars and vectors. Let's get started. Let's define scalars. So what is a scalar? A scalar is something that is just a number. If you want to get sciencey, you could call it a magnitude. And magnitude is just a fancy way of saying a number of something. A vector, on the other hand, is also a number, but it's with a direction. So a scalar is a number, and a vector is a number with a direction. So the two big ones that you hear most often in physical science, one of them is speed versus velocity. So speed is just how fast, and that is just a number, you know, like 60 miles per hour. So that is a scalar. Ooh, I just spelled scalar wrong. That's horrible. Nobody needs to know about that. So speed is a scalar because it's just a number, like 60 miles per hour. But velocity is a vector because it has a direction. So you could say 60 miles per hour to the east, and you just took a scalar and turned it into a vector just by throwing on this east here. So speed is a scalar because it's just how fast. Velocity is a vector because it's how fast, which way. All right, so we can represent vectors with arrows. So here you have a box sliding along this way at, I don't know, 10 meters per second. This is a vector because I told you how fast and I said which way. And kind of a nice thing about vectors, it allows us to think in pictures, because what if I wanted to say 20 meters per second? If it was 20 meters per second, I'd just draw a longer arrow. So anyway, that's speed versus velocity. That's one of the two big ones. And the other big one is distance versus displacement. Distance is just how far, and displacement is how far from someplace. So if I say I'm 17 miles from home, what's that? Is that a distance or a displacement? 17 miles from home is actually a displacement because I say how far from someplace. So I'm 17 miles from home. How could I turn that into just a distance, into how far? Well, to turn 17 miles from home into a distance, I would just have to get rid of this stuff. So now 17 miles, that is a distance. So what does the odometer on your car show? The odometer on your car just shows you how many miles you have on the car. It doesn't tell you how far you are from home or anything like that. It just gives you a distance. So that's speed versus velocity and distance versus displacement. I'm 3.5 minutes. What are some others here before I go? Let's see here. Temperature. Temperature, that is a scalar because it's just a number. You know, it's 70 degrees today or whatever it is. Force, if you're pushing on something, that is going to have a direction. So force is a vector. And momentum is a product of mass and velocity. So momentum is also a vector. So momentum is going to have a direction. Like my car example up here, this box or whatever this was. This thing, if I give you a mass of whatever 10 kilograms, it's going to have a momentum going to the right. Acceleration is a change in velocity over time. So that one is also a vector. It has a direction. Like we like to say that gravity is an acceleration downward. If you fall, you know, you speed up at about 10 meters per second each second. So acceleration is a vector. And your weight is also a vector. Why? Because your weight always pushes which way? Your weight always pushes down. So your weight is a vector. Lastly here, energy gosh, I've done 4 vectors in a row. Energy is actually a scalar. That's just a number. I sure do have a lot of energy, or there's energy in this can of gasoline. Looks like a teapot, but we're going to say it's gasoline. So the energy in that gasoline doesn't have a direction. It's just a number. So energy is a scalar. So I'm almost to 5.5 minutes. That's probably good enough. I hope you understand the difference between scalars and vectors.